Okay, so hi everyone, welcome back. So now we are going to
Hi.
solve, yeah, thanks. Now we'll solve one question from LeetCode, and I'm joined by Chitresh and Saurabh. We'll discuss one LeetCode problem that we haven't solved before, and you can understand the thinking process behind solving the problem. So let's start. Okay, so we have these questions. Yeah, you can choose any questions. Which one you want to solve? Longest time difference to city scheduling, best time and start with cooldown. We have selected all the medium questions and sorted by frequency. Let's do. You have any preference? Which question you want to solve?
Yeah, you can select anyone.
Okay, so let's select this one. Let's solve today three question.
Okay.
Okay, so we have this question. Given an array of positive integers, consider all the binary trees such that each node has at least either 0 or 2 children. The values of array correspond to the values of each leaf in an in-order traversal of the tree. So each node can have 0 to 2 children, that point is clear. I didn't get the values of array correspond to the values of each leaf in an in order traversal of the tree. Okay, so they
Yes,
are in the
like
same order. Yes.
yeah,
Yes.
these two diagram shows like
Hmm.
6 to 4 are the leaf nodes.
Yeah. So they are. Yeah. So if we do a in order traversal, then they will be in the same order, something like that. The values. Okay. Okay. So if we do an in order traversal of that tree, we will get 6 to 4, and the array is 6 to 4, right? That is the. Okay. The value of each non-leaf node is equal to the product of largest leaf value in its right and left and right subtree respectively. The value of each non-leaf node, suppose 12, is equal to the product of the largest leaf value in its left and right subtree respectively. So like 12 will be product of 6 and 2. 24 will be product of 12. Okay, so 6 into 4, right? The largest leaf value. And 8 will be product of 2 and 4. 24 will be product of 6 and 4. Okay. So among all possible binary tree considered, return the smallest possible sum of values for each non-leaf node. Is guaranteed that the sum fits into a 32-bit integer. Like, so we have to generate the smallest possible sum of values for each non-leaf node. Like for this 6 to 4, we have to make it 12 and we have to make it 24, right? Because we cannot do better than that. Okay.
Yes.
So the I think we have to select the second one, right? Because although both satisfy the properties of point 1 and 2, but tree 2 is better, is has the less smallest sum.
smallest value.
Yeah, so we will
Yes.
select the 32. Okay, good question. So how would you guys try to solve it?
Can we have a look at constraints?
Yes. Like if you take the brute force, so you generate all possible trees and find out the least sum, right? And it's, I think it will take 2 power n if to generate all 2 power n to generate all possible trees, and which will be okay because n is 15, so 2 power 15 can be it won't give you timeout, right, for to generate it. No, it's like array's length is 40, so 2 power 40,
40, yeah.
2 power
15 is the
40 will,
limit.
yeah, 2 power 40 will give timeout for sure. What do you guys have any other approach? How would you solve it? Like I can't think of anything that can. Maybe we don't need to generate the tree. Maybe we can do it in some other way, you know. But how would you do it? So if you take 6, 2 and 4, how many trees can you make
Yes.
from this? Like you have to make a leaf, like a non-leaf node that is 12, and one can be 8 and one can be 24. Like either you can have like 12 and 8, or you can have 24 and 6. Like we can have 12 and 4, and you can have 24 and 2, right? And then in the you can have 48, or I mean if you have these two node as the leaf, then like you have to make a 12 node whose children will be 6 and 2, right?
Yes.
Or you can have a node 8 whose child will be 2 and 4, and like if you take this, I'll just so if you what I mean is you have 6, 2 and 4, you have 6, 2 and 4, right? So you can take 6 here and 2 here, and you can have a 12, and then you can have 4 here, and you can have 48, right? No, you'll have 6 into 4.
24.
24. So
24.
24. So that will be one possibility. And like this, there can be also other possibility, like you can have 6 and 4 as the leaf node, or then
No, but we are given the in-order traversal, right?
Okay, yeah. So we cannot
2
do.
and 4 can be considered.
Yeah, so we can consider 2 and 4. So 2 and 4 will be 8.
8.
And then we will have 6 here, like 2 and 4, and then 6 and 8 we will have 24, right? Any other case?
Why can't we replace 2 and 6 in this?
In that way, the in-order traversal will be different, right? For the
Yeah.
leaf nodes.
So we have to maintain the order of 6 to 4. We cannot change it.
Okay.
Yeah, so that's good, because then we don't have to consider all the combinations. It's just a different order. So 6 to 4. Okay. And is there any other possibilities? We have taken 6 to 4, 6 to and 4. I don't think there is any other possibility, right? To make the tree.
No.
Oh, then
I
we
think,
don't have. Yeah.
I think we can approach this problem as partitioning an array.
Yeah, something like that. We don't have to make it a tree. We can do it, some other way. We don't think in the tree way. We can think of in some other
Yes.
way. Yes, that was I was thinking. So we have, and we don't need to consider the combinations of 6 and 4. The combination will always be consecutive, like 2, 4, and like then we have 6 and 8. Yeah, so like so for an array, okay. Or we can also make it a tree, and we can have a value to find the maximum. Like if you make a tree, like it will have left, right, and the largest like leaf element. Like the tree node will have 3 things. Like if I write it, I'm just brainstorming. So tree node will have 3 things. One will be left and will be right, and it will have maximum leaf node. The left will be another tree node, and right will be another tree node, and then we have maximum. It will be integer. And if you have 2 tree node, yeah.
I think we need to have 2 maximum leaf nodes, one for the left subtree and one for the right subtree.
Now I was thinking that if we have this tree node, and then we can combine 2 tree nodes to make another tree node. Like suppose we have 1 tree node and which is left, and 1 tree node is also right. So from this tree node we can make one more tree node that has left and right, and we can compute the maximum leaf node from the maximum leaf node of left tree and maximum leaf node of right tree. Something like that I was thinking. Like if I have we can construct one given left and right tree node, generate the parent tree node by so the maximum leaf node will be like the maximum of left and right, and okay, but that might not be the right approach to solve the problem. Maybe there is a easier way. We don't have to make the tree, because if you make the tree it can be a bit complicated. Can you solve it without making the tree? Like just array manipulation? The first has non-leaf node of, and you can also have a sum, non-leaf node sum, and then we can combine these two and get the
Yes.
possible. Like we can also have a maximum leaf node and non-leaf sum, and we can generate something like, if we have this array like a1, a2, a3 like this, what we can do is we can take a1 and a2, make a tree node from these two, and then consider like the other array as the from, and we can have a recursive function, and then we make one tree from this, one tree from this, and combine those. Or we can have a1 as a leaf node, and then we can have a2 and like this as a tree node, you know, and combine all this and find out and generate all the tree node and generate the solution, the minimum, and keep a counter of minimum thing. Well, what do you guys think? This can work? I think it will be
Like we will
yeah.
we will
Right.
try like all different possible ways in which we can split the array.
Yeah, exactly. We can split it like a1, a2 and like this. Then we can split this like a1 and like this, and like where a1 will be the left node and this will be a right node, and here a1, a2 will form a tree. The parent of a1, a2 will be the left node, and from this tree we will have a right node. Something like that I was thinking.
Okay.
And generate this tree, something. Okay, that would be my approach, but it will be very hard, a bit hard to code. Do you guys have any other ideas by which you can solve this problem?
I'm not getting any idea for this.
Saurabh, you have any other idea?
Like, sir, I'm thinking about one, but I don't know whether it will work or not.
Okay.
6.
Okay, you can take a hint maybe. Do a DP, where DP ij is the answer of subtree array I and array j. Okay. Okay, now let's try using this approach. DP ij is the answer of subarray array I to array j.
Okay.
How would you use this hint to solve it? If we have like this dp, if we have dp ij, how can we get the answer? Like, how can we get dp ij from dp of I k and dp of kj? What would be the relationship? So we can think that dp ik is a like subtree and dp kj is a subtree. So from this subtree we can make dp of ij. dp of ij will like maybe it can be the sum of non-leaf node.
I think dp of ij will be equal to sum of dp ik, dp kj plus the product of maximum from these two subarrays. Because
Yeah.
dp of ij we will have a new node.
Yes. So it should contain two things, right? One is the product of sum of non-leaf node and the largest leaf node, right? It should have two things. Like dp of ij should contain two information. One will be the sum of non-leaf node and one is the largest leaf node. If dp of ij contains that, so we can calculate it like from this. So suppose dp of ik 0 is the, so dp of ij will be like for all k in I plus 1 to
Yes.
j minus 1 like yeah, so dp of ik 0 plus dp of k of j, I mean k plus 1 and j 0, right? We have to have the sum and it will have plus it will have dp of ik plus 1, right? And the largest leaf node will be maximum of like this dp of does it make sense? Like dp of ij will, okay, I'm explaining once again. So dp of ij will contain information. One will be the sum of non-leaf node and one will be the largest non-leaf node. Okay, it will have two information. Suppose it's like a map ij to this.
Yes.
Okay.
So now the question is, how can we make ij from ik and kj? So for all k in the range of I plus 1 to j minus 1, we'll update the dp of ij as the first element will be the sum of non-leaf nodes. So as you have told, so it will be sum of non-leaf node of I to k and sum of non-leaf node of k1 to j plus largest leaf node of I to k into largest leaf node of k1 to j.
Yes.
And we have to update the largest leaf node, that will be maximum
for I
of
to J.
Maximum of the non-leaf node of I to k and maximum of non-leaf node of k to j.
A plus 1 to J.
K plus 1 to
Yes.
j.
And we directly have the value of dp of II.
Yeah. So do you want to, yeah, so we can try to solve it like this way. Do you think this should work?
Yes, I think we can try this.
Okay, and okay, let's see the hint 2 and maybe Yeah, so for each possible way to partition subarray ij, ik and j, the answer is maximum of area of yeah.
Yes,
So
yes.
that's the thing.
Hmm.
And
Yes, we
dp
do
of
this.
this plus dp of this. Yes. Okay, so we don't need to compute this because the largest leaf node will be maximum of area of I to k and k1 to j and plus dp of ik plus dp of k plus k1 and j, right?
Yes.
Okay, so how would you implement it? I have a doubt. So when is the product? Don't we need to consider the product of actually do we need to consider the product of two?
Yeah. Yes, like product will be part of our dp of ij.
Yeah,
It will not be a part of max. Max will only have leaf.
max will only have
Max.
leaf. Yes, yes, yes. And dp of ik is sub is the
Is
answer
the
for
sum
subarray.
of
Hmm. Yes, yes, yes. True.
yeah.
Mm-hmm.
And I think for all dp of ii,
Mm-hmm.
dp of ii will be 0
Mm-hmm.
and maximum will be the value itself.
Yeah, yeah.
Because for leaf nodes we don't have inner nodes and the maximum is known to us.
Okay. So like if we have to consider like for like let's initialize dp equal to 0 for I in range of length of array and for j in range of length of we have made a 2D array. Okay. So I think for I, j and k we have 3 loop, right? For I and j and k. Like for I in range of length of array, for j in range of I to length of array, for k in range of I to j, something like that. And if I and j are equal, then we consider dp equal to will be what will be if I and j are equal.
Yeah,
So
and this will be a tuple, no? dp of ij will be a tuple of 2 values.
but I think we don't need to have 2 values. We just have to have the sum of the non-leaf node, because the largest leaf node will be just maximum of it will be just maximum of array I and j. We can just compute it very quickly. We don't need to store it in the dp to make it simple.
But every time calculating, we will take additional order of n time.
Yeah, right. Yeah, right. So then, okay, we can store it also like, yeah, let's store it in this. Okay, fine.
Yes.
So dp of ij will be, so if I and j are equal, if I equal to j, then we have
dpij equal to 0 comma ARR of I.
0 comma ARR of I, right?
Yes.
And okay, and let's also consider if j equal to I plus 1, only 2. For in this case, what will be the answer?
Okay.
It will consider, if we have only 2 element, what will be the answer?
For 2.
If we have only 2 element, suppose the input
Okay, yeah.
is only,
Then it will be product of those two.
yeah, so it will be product of those two. So it will
ARR
be,
of I into ARR of j, comma max of ARR of I. No, in the second condition. That is I
sorry,
equal to
yeah.
j.
It will be,
Yeah, ARR of I into ARR of j.
of j,
Yeah, and that second value will also get updated. Max of both two.
yeah, it will be max of, is it okay? Because
Yes.
so like for 6 2 we have 12, so the product and the maximum will be 6 and 2. Yeah, so this is like for example, if we have 6 and 2 array,
Yeah.
the dp will be
12 comma 6.
and 6. So 12 is the product
Mm-hmm.
and 6 is the maximum leaf node. Okay, so else, so if this,
But I think this j is equal to I plus 1 condition can be included in this k for loop for k in range.
okay, yeah, we'll see. So like, yeah, if
Okay.
we can do it, then we can do it later. So if else, for like we have 3 element, yeah, we'll do it later, optimize it later. So let's just implement
Yes,
it.
okay.
So for 3 element in the array, it will go from I plus 1 to j minus 1, right? We have dp of I, k, and we
In
have,
this loop, j minus 1 will not come, no?
yeah, it will be like j, like, because it will be
Okay.
k and j, right? So we have 2. So for 2 we can do it like dp of I
J.
j
dp
will
of
be
I, j.
maximum of, will be so we have to consider all the cases, right? So it will be maximum of, so we have this product and we have the maximum leaf node. So from this, how can we calculate the dp of ij? It will be, as we have mentioned, it will be so I'm a bit lost. This question is a bit complicated.
Yeah, it will be dp of ij is equal to min of dp of ij. Like we can have the existing value.
Yeah. Okay, let's just we'll update it later. So the product will be, what will the product? Product will be
Okay.
array
it
of
will be
dp of I
dp of ik
0.
into dp of yes.
Okay,
Correct.
let's see. Product left will be dp of I k, and product right will be dp of k. Oh, so we have to 1 second. Yeah, so now left is this, product right is dp of k and j of 0 and 0, and maximum of left equal to,
Will product right be dp of k plus 1 to j?
no, I mean from ik and kj we have to make the product, right? So product left is like dp of I to k 0, and product right, so the first one is product and second is maximum leaf, right? Max left is,
Yes.
and max right is dp of k to j. So now from this left right we have to make the product and maximum, right? Is it a bit confusing?
No, what I am saying is like in this product right, we must take dp of k plus 1 to j, or else k will be part of both, like left and right. Like
you are right. So I to k, and you're right. So it would be k of k plus 1 to j, and k plus, correct. So we have this and we have this. So it will also be Now how can we get product? So product will be,
And in the for loop also, I think we can start from I, or it will not consider dp I also.
True.
Yes. Okay. Now product will be product left into product right,
and maximum
max of max left, max right.
and dp of I j 0 will be maximum of minimum, right?
Minimum.
Minimum of and 1 will be maximum, right?
Yes. This will be maximum.
And we have to return the
dpij, and I think we will have to make one more change. Scroll up. In line 34 we will have to change these default values 0, 0, because first value we are minimizing, so it needs to be some bigger value.
True.
And second value we are maximizing, so it needs to be some small value.
Like 0 is okay?
0 will be okay because we are only given positive integers.
Okay.
Yes.
And answer will be dp of 0 and length of dp of 0 and the length of array -1, and which element? Product, right? Or sum? We have to give the sum. So
0.
0 is product, right? 1 is sum. We have written the sum, right? The sum, not the product, or what?
Okay.
Yeah.
Uh,
But I think we are missing one thing. So we should only update when the maximum value is less than the value. Like not all the cases. Like we should only
yes.
do it when the maximum, like if the if we get a better value of maximum value. I mean, if maximum value is less than this dp of this, then only you need to update it, right? Because and product is should be 0 and this should be maximum, right? Float of, because first is product and second is sum, and we need to consider the minimum of the sum. We have to minimize this value.
I think we are maximizing the second value.
Yes, we are maximizing the second and
Yeah, so I
minimizing
think
the first.
earlier it was correct.
Okay. Okay. Fine. This is the my algorithm. I don't have much time, so let's see the answer and let's see if we move the right direction. Okay.
Okay.
Oh, it's greedy. Let's try DP. Okay.
Yeah.
Yeah, so this is the so we have left I and this 9 TP. Let's try to see one other example. It's like which one we should like. Let's see. It's not a medium problem. It's yeah. This one looks easy to you, or
Just like we can consider it as a medium hard.
yeah. Okay, I have to go. So I have a meeting right now. So you guys can
Okay.
see and like write a solution about it. Okay.